In this video, I go through the C64MegaCart Programming Tool electrical checks, assembly, and software setup. So when you order from PCBWay or you order from me, you will get at least one board, which is a programming board on the right, and also you might order some of these cartridge boards on the left. So when you get new boards, it's always a good idea to check if they are built correctly and they have safe electrical connections. So with my multimeter, I'm using the continuity mode here. To check there are no shorts between the 5V and ground pins, there's a little debug header here that you can use to access these voltages on the board, and also that there is no short between the 5V and ground, and then the 5V and the 3.3V, and there is no short between the ground and the 3.3V. I'm also making sure that the 3.3V is only connected to the pins that I expect on the Raspberry Pi header, and that the 5V it also is only really connected to the correct pin on the Raspberry Pi GPIO port, and that the ground is connected correctly. It's also a good idea to make sure that when you are checking ground, that it's also routed correctly, especially for the C64Mega cartridge board. So again, ground is connected. There's no short between ground and 5V. In other words, there's no beep from the multimeter, so there's no continuity, there's no connection. And also that the ground and the 5V on the cartridge board go to the correct pins on the ICs. So the bottom left pin on these ICs is usually ground, the top right pin is usually plus 5V. These ICs are very small. The leads on the ICs are very small, so it's quite fiddly to actually check. If you don't have a multimeter which is capable of giving you continuity checks, then don't worry about it. To be honest, I've never had any continuity issues from the boards that PCBWay deliver to me. They are already checked when they're assembled. So you don't really need to do this, but I always do, just for complete safety purposes. It's also good to do a visual inspection. So I look at these under a microscope just to make sure that all of the traces and wires and all of the pads and everything don't have any solder blobs connecting them, or solder bridges rather, connecting them all, and it all looks very nice and clean and very neat and tidy, doesn't it? So that's the end of the board inspection process and electrical checks. Now we go on to the assembly of these boards. So now on to the assembly of the programming tool. But first we're going to have a quick little look at the cartridge board itself. You can see the flash memory IC there on the right hand side, that big IC there. We have these associated logic chips which deal with the banking of the 8KB memory banks within that, supplying that to the Commodore 64. We have a nice debug header as well on this revision of the board, although I might remove that debug header because we don't need those probe pins anymore. We can see that there's a hole there, which is good for a mounting hole in typical cartridge cases. This debug header does take up some space on the board, you see, so sometimes it might be an advantage to remove that and add extra flash memory instead. So this board will safely plug into the programming board. You can see where it plugs into, right? It's that great big slot up on the top there. So we have these LEDs. This is the power indicator LED. And the LEDs along the right hand side are for status. So if you don't have like a display output for the Raspberry Pi that you connect, then those LEDs will give you visual status. This is the GPIO Raspberry Pi connector. Usually GPIO connectors on the Raspberry Pi are facing upwards, so that has to face downwards, of course, so you can plug it in. There we go. And that tells you the orientation of the GPIO header for the Raspberry Pi. It matches the silk screen printing on the Raspberry Pi board. You can see that it says that the Raspberry Pi should be underneath. And all of these components in the middle are to do with the voltage level conversion. So there's the nice LEDs there. We've also got a push button as well that we can use to tell the programmer board to start erasing or writing data as well. We'll get onto that on the software side of things. This is a Raspberry Pi. I don't supply these. You'll have to buy your own Raspberry Pi. This is a Raspberry Pi 5. I've added an extra header on top of the standard header. It just allows me to plug and unplug boards more easily because it's slightly less of a snug fit. It also avoids wear and tear on the main Raspberry Pi header. You don't need to use that, of course. You can plug the programmer board directly in. Just make sure that you've got the pins lined up correctly. Now, before you push anything together with any kind of force, just make sure, look around, make sure all of your pins are in the expected holes, that there are no overlaps or pins jutting out or anything like that. It all looks good. So I'm going to squeeze those together. It doesn't need much force because I have that extra kind of like extension header on there. It allows it to be connected a little bit easier, but you don't really need that. It's just to avoid wear and tear on my Raspberry Pi board. So because the Raspberry Pi sits underneath, you can see that the programmer board is raised up. So we need to have something for the programmer board to sit on so that we can safely insert and remove cartridges. This book is just about the right width. So it sits neatly underneath there, and then the Raspberry Pi is just underneath and to the left. The cartridge then goes into the cartridge slot, as you would expect. Now this programming board basically emulates, under Raspberry Pi control, all of the signals that you would normally expect on the Commodore 64. So you can see there that that's the back of the cartridge, and that the front of the cartridge matches the top or front, which is printed underneath the silk screen, underneath the cartridge port there. So that tells you which orientation you should plug the cartridge board in, or actually if you've got the cartridge board already in a cartridge case, then it will also allow you to plug that in as well. There's enough space around the sides for a cartridge case. If you've purchased one of the programmer boards, or if you've purchased a decent number of cartridges from me directly, then I might include, if I have stock, one of these MegaWang 2000 Turbo Edition, kind of like sparkly badges as well. Stock is quite limited of these badges, but if I have them on hand, then I'll throw one in the packaging for you free, just as a little bonus. And it's a nice little badge as well. The MegaWang 2000 Turbo Edition is, of course, the retro-themed arcade video and audio hardware that I've been working on in separate videos on this channel. So let's disassemble this quickly. Let's get rid of the book. There we go. So this is what you will get if you order a programming board, at least one cartridge board from me. You'll get that badge on the left-hand side. So in the next part of this video, we will go into how to set up the software so that you can use the programming tool to program quickly as many cartridge boards as you want. So here we are on the GitHub project page for the C64MegaCart. We're going to go through to the cartridge programmer tool sub page. So there are two pages on here, one for the cartridge board and one for the programmer tool. So let's scroll down. The documentation for the programmer tool goes through things like the command line options, the wait button, the erase block or erase whole cartridge, command line option write and read and loop. it gives some example command line options for using the wait button and then erase and then write a file and then looping back again. So you can tell the programmer board to wait for the button to be pressed there and then do a write and then or an erase and then a write, and it will show the status on the LED. So once you set it up to do something, you can just leave it doing that over and over again. But to be able to set up the software, we need to be able to SSH. That's some setup steps. First time only really setup that you need to do. You need to SSH into your Raspberry Pi. I'm not going to go through how to set up your Raspberry Pi to be able to SSH into it because that's on the Raspberry Pi website. But you just follow the instructions on my GitHub page to then install Git and then clone the wiring Pi library. You can also clone it from my repository as well in case the original URL disappears, and then just use the GCC tools to compile that library. So there we go, that was a very quick library compile of the wiring Pi library. It just needed an update to make sure that the latest version is installed, because sometimes the Raspberry Pi doesn't have the latest version. And then there's the command lines that you need to run to get the programmer tool source code, and then use GCC to compile it. And then that's it. It's ready for use. You can see there that there is a PyCart tool executable in the directory now, and then we can test that executable that was just written with this command here. So this will wait for the button to be pressed. It will then erase and then write the scrollerbanks.bin file to the cartridge, and then it will loop again back to the beginning of the command line. So you can see there, the LED on the programmer board is now flashing away. I press the button, and then the first LED lights up. And then if you are logged in via SSH, you'll be able to see that the status register shows the erasure process of the flash memory. It then shows the status of writing each individual bank. During the writing process, it also verifies that the data is correct on the flash memory. So you don't need to do a separate verify. It already includes the verify step in there during the writing process. So this, because it's a 2 megabyte binary file, it will take about a minute to erase the whole cartridge and then write it. If you order fresh new cartridges from me or from PCBWay, then usually the flash memory is completely erased. So you can skip the -- erase command line option, and you can just use the write command line option to just write the file into an already erased flash memory. There you go, and after that's completed, it waits for a button to be pressed, but you can take out the cartridge board, you can push in a new cartridge board, you can see the LED is flashing on the top right hand side there, and then once it's in, then you press the button again, and it goes through and then erases your new cartridge PCB. And then after the erasing has finished, if you opt to use the erase command line option, then it will go through and then loop around and then do the writing again. So that's what the -- loop command line option on the end of the command line gives you. It gives you the ability to loop back to the beginning again, so that you can set up this board to do multiple erases and multiple writes of different boards. It will always show you its status for when it's accessing the cartridge or when it's ready for the next cartridge. It will also show you an error. So if I yank out the board halfway through, there we go. We've got all 4 LEDs flashing to indicate that there's an error. So we'll just put in the cartridge board, and then we'll press the button to clear the error, and then we'll press the button again to start the next erase and write cycle. And there we go. It's just erasing and writing again. The SSH terminal here, the shell rather, is just useful for seeing a textual representation of what the programmer board is doing. But you don't need to look at it all the time. I think the LEDs on the right hand side are adequate for telling you what it's doing at a particular time. So it flashes the LED, the last LED, the fourth LED, to say that it's ready and waiting for the button to be pressed. The first LED means that it's accessing the cartridge. And if you just, for example, just say, I just want to erase a cartridge, but no, there's no loop on the command line, then the third LED will light up when it's finished erasing. The second LED will light up when it's finished writing or reading from the cartridge, for example. So there we go. So that's how you can use the programmer board to basically rapidly erase and write, optionally erase and write the flash memory on the cartridges. You can also use the read option to read data from a cartridge as well. So we're just reading what was just written to that cartridge. We're going to read back the data. Reading is a lot quicker than writing. It's about twice as fast as writing data to the cartridge, and that's because reading is a simpler operation. Writing is actually involves more commands being sent to the flash. So you can see there I can use the diff command to do a diff between the original scroller banks binary file and then the read data binary file. I can erase the cartridge in one step, so you can see here how long it takes to erase the entire flash memory. And that's it. The flash cartridge has now been erased. I can then do a write without a preceding erase, because I know that the cartridge, say for example it's just been delivered, I know that the cartridge has already been erased. So I can just do a very simple write. And if I just do a very simple write, then you can see it just goes straight into writing data to the flash memory on the cartridge. There you go. And remember that during the write process, there's also a verify to make sure that the data is good. So we know that the data is already good. If there's an issue or error encountered as it's writing data, then of course it will flash the LED lights again. If there's an error during the erase, likewise it will also flash all 4 LED lights on the board. So you know that there's a problem with that particular cartridge board that you've got plugged in. To be honest, I've ordered numerous cartridge boards of this design from PCBWay, and none of them have any issues. All of them behave correctly as you would expect. So I'm just writing all of that 2 megabytes of data, all 256 banks of 8 kilobytes each. So 256 times 8 kilobytes is 2 megabytes, of course. And there we go. The write to the cartridge, it has been completed. There's another command as well on the command line option where you can erase a block. So erase block is a partial erase of a part of the flash memory. So if you use, so for example, erase block with, say for example, what's it, 253, I think it was, is a good example, then it will erase memory in the flash memory at a particular offset. There we go. And this is not quite at the end of the cartridge memory, but it's near the end of the cartridge memory. You can see that it doesn't take that long to erase an 8 kilobyte block in this case. Depending on the geometry of the flash memory that's used, there will be some 8 kilobyte blocks, there will be some 64 kilobyte blocks, and I think 16K or 32K blocks as well. It's not all 8 kilobyte blocks, so you have to make sure that the bank number that you use corresponds to the expected block size in the data sheet for the flash memory. So anyway, that memory address basically maps to the expected memory address when you use, say for example, bank 253, it's 253 times 8 kilobytes. So if we read back that data now, then we're reading back the whole cartridge to a different file. And then I've got a little diff command here in the documentation on this page. So if I then run this diff command, there it is, there's the compare, and then it pipes it through to mock. Yeah, that's right. So this will show the binary difference between the original binary file and the binary file that contains the just read data after one of the blocks has been erased using the erase block command, right? So there we go, the original file and the original red data file was a pristine copy, but the red data 2 file shows here, if I scroll up, find the beginning of this binary diff, it should say that the binary diff or the binary differences actually start at 1FA00 as expected. There we go. There. So that second file that we read was after one of the blocks had been erased, and there you go. So the data should be 0, but the erased data on the cartridge for that bank only is FF, which is 255 in decimal. So there we go. That goes through the how to use the software and how to install and compile and then use the software on the programming tool. I hope you found this video useful, and I hope to catch you around next time. Have a great day, evening, or night, wherever you are.